So, what is relative rates? Relative rates are rates of change associated with two or more related quantities that are changing over time. For example, consider a spherical balloon being inflated so that both its radius and volume are increasing. The volume V of the balloon is related to its radius r by the formula V is equal to 4 over 3 pi r cubed. As the balloon is being inflated, the radius r increase over time and consequently the volume V also increase. To understand how the rate of change of the volume dv over dt related to the rate of change of the radius dr over dt, we can differentiate the volume formula with respect to time t. Why we use related rates? Related rates problems involve two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time. Implicit differentiation is often used. Apply maximum and minimum problem involve finding the largest or smallest value that a function can take within given domain. Why are they important? The first is engineering. The reason is designing structures or systems that use the least amount of materials. The second is economics. The reason is maximizing profit or minimizing cost in business.
Here is the problem statement. Azri is a young successful businessman. He wants to produce a new package for his latest product, which is premium skincare. He wants a new packaging in a cylindrical shape. The figure above shows the new packaging which has HCM height and RCM radius. The packaging is made to hold 500 centimeter cubic of liquid. Hence, find the minimum surface area of the
How to solve
packaging.
this
This problem. First, we must understand the problem. Second, find the derivative. After that, let the derivative equal to 0 and find the values of the variables. Lastly, we make the second derivative test. If second derivative test is more than 0, it is minimum value. If the second derivative is less than 0, it is maximum value. Given the volume of cylinder is equal to 500 centimeter cube, as we know the formula of volume of the cylinder is equal to pi r square h. Since both are volume of cylinder, we can make the equation pi r square h equal to 500. Now, let's express h as a subject. H is equal to 500 over pi r square.
Then we will substitute H into surface area of cylinder. So formula of surface area for cylinder is 2 pi r square plus 2 pi r h. Since H we get 500 over pi r square. So we will get 2 pi r square plus 2 pi r multiply 500 over pi r square. So the last we will get is 2 pi r square plus 1000 over r. Since we will find the first derivative, we will let r become the numerator. So a is equal to 2 pi r square plus 1000 r power of negative 1. So dA over dr is equal 4 pi r minus 1000 r power of negative 2. So we will bring back the r to the denominator. So we will get 4 pi r minus 1000 over r square. So we will let the dA over dr equal to 0. So 4 pi r minus 1000 over r square is equal to 0. So we will bring the negative 1000 over r square to the next side, we will get 4 pi r square equals to 1000 over r square. Then we will bring the r to the other side. So we get 4 pi r power of 3 equals to 1000. Since we will let r become a subject, we will bring the 4 pi to the other side. So we get r power of 3 equal to 1000 over 4 pi. So r equal to root 3 1000 over pi. So we get r is equal to 4.3. Since r is more than 0, so r is a minimum value. So next, we will subs r into equation of surface area for cylinder. So formula for surface area of cylinder is 2 pi r square plus 1000 over r. So we will get 2 pi multiply 4.3 square plus 1000 over 4.3. So we will get the surface area of cylinder is 348.73 cm square.
Example of maximum and minimum problem in real life. First one is on a geometry. Finding the dimension of the rectangle with the largest area that can inscribe in a circle of a given radius. The second one is the radius. Calculating the angle at which a projectile must be launched to achieve the maximum range. Okay, now this is an example question that you can try. A rectangular football field with an area of 4050 meters square is surrounded by a running track. The track is 12 meter wide on the two sides and 10 meter wide on the other two sides, as shown in the figure. Let x and y be the length and width of the football field respectively. A. Show the number of combined area is A equals to 4x plus 360 over x plus 84. For question B, what dimension of the football field will minimize the combined area? And for the last question, what is the minimum of the combined area? So, finding the right formula and carefully working out both of the first and the second derivative are important steps. By doing this correctly, you can figure out whether you have a maximum or minimum cost. This approach helps you to get a clear and accurate answer. Using these steps correctly is the key to solving where you need to find the best solution possible. That's all from us. Have a nice day everyone. Thank you. Bye bye.